Have a look at this graph. Now it looks so weird. We've never seen this graph before. It looks tricky, and finding its equation also looks very tricky. So how do we do this? Well, don't worry. Welcome to my channel. Today we're going to be exploring hyperbolas and what they really are. The graph we saw back there was a hyperbola, and in this video we're going to be talking all about what are hyperbolas and their equations and generalizing them. So let's look at the visual graph of a hyperbola. So this is how a hyperbola actually looks like. It's actually two kind of exponential curves almost. That's what it looks like. So it's quite an interesting graph. And now let's look at how we can generalize it and graph it. Alright, so here's the general form of hyperbolas. Y is equal to k divided by x minus a plus b. So over here, each of these variables represents some aspect of our graph. So our k is going to be representing our stretch factor, which is how kind of spaced out our two lines of the hyperbolas are going to be. Then we've got our a, which is our horizontal asymptote. Sorry, our horizontal shift. So it basically controls our vertical asymptote. Basically, an asymptote is a line that the graph is trying to reach, but it never crosses it. It never goes beyond it. So, for example, x is equal to 1. Our graph is never going to cross that point, and that means at x is equal to 1, that is going to be its asymptote. So, in that case, our a is going to be 1. So that is how we can kind of control the vertical and horizontal asymptote. The vertical asymptote is controlled by A, and the horizontal asymptote is controlled by B, because B is kind of looking at how up the graph is or how down the graph is. Now let's look at this graph on Desmos so that we can kind of visualize how each of these variables control our graph. Form of our hyperbola. And we're going to look at how each of these variables are going to control our hyperbola. So our k, as you can see, is kind of controlling how close our hyperbolas are together. And as you can see, as soon as it reaches 0, what happens is that we're dividing by 0. So y just becomes the value of b, because this whole bit becomes 0 and b is 1, so we get a line at y is equal to 1. But if we go into our negatives, our graph reflects. Our graph tends to go this way. And as you can see, again, our k is just controlling. As we go higher, the two lines get further apart. And as we make the k smaller, it comes closer and closer together. Alright, so that's the job of k. Now let's look at A and what I meant by the vertical asymptote. So as you can see, as we move across over here, the vertical asymptote is this one. This is a line that the graph is trying to reach, but it's not able to reach. So that is our vertical asymptote, and our A is going to be controlling that. So when A is equal to, say, 5, you can see the graph is trying to approach 5, but it never quite gets there. And basically, as a result, when we move our vertical asymptote, that moves our whole hyperbola. So now lastly, let's look at our B. Our B is controlling our horizontal asymptote. So as we go up, it goes up. So this whole line, this is the horizontal asymptote, which is at x is equal to 4.6 now. Sorry, y is equal to 5.3 in this case. So if we set it to something like 5, you can see that this line is trying to approach 5, but it's never gonna quite get there. So that's what asymptotes are, and that is how this graph kind of works. So now let's look at trying to generalize hyperbolas. So here we're just going to be translating the shape, and it's going to be the fixed shape. So we're not changing its scale or anything, we're just going to be moving it around. So in our general form, we looked at how we can use our A and B to kind of move our graph around, and that is what we're going to be doing over here, and we're going to be playing around with a bit of domains as well. So let's get into it. Little equation that we had, and this is how our shape looks like currently. So how can we move this around? What I'm going to do is just copy this and paste this so that we can start modifying it. So firstly, we know that we had, by the way, ignore this line, this is just the answer I'm trying to reach, just for my own guidance, but I'm going to explain every bit of it. So first we need to figure out how we're going to move it horizontally. So that means we're changing its vertical asymptote, which is done through our A. Now if you remember, our general formula looked a bit like this. Right? So obviously we had our A, but our A was responsible for moving it across, and remember we were always taking it away. So that is why I'm going to go ahead and do x minus A. So this is how it looks like right now. So our domains are a bit messed up right now, but we'll figure it out together. And now we've got our vertical shift. So our vertical shift was done by controlling the B. As you can see, if I activate this again, we can see that with our B, as I change it, it goes up as I increase and down as I decrease it. So obviously we're adding on our B. Over here we were subtracting our horizontal, so we're adding our vertical. So I'm just going to add on my B. Now, so we're done with kind of generalizing a little bit, and we can move it around, we can move it up and down, which is perfect. But now we need to work on our domain. Now, something we need to understand is that the width of the shape is always 9, because 10 minus 1 is 9. So if we're adding on our A, which is our horizontal shift, we don't really mind our B right now, because that would be a part of range, which is when we're looking at Y values. But right now we're just looking at X values, and that should be enough to make our shape looking like this. So we're going to use our A value. Sorry, excuse this rain in the background if you can hear it. But we're going to use our A value and figure out, kind of add it onto here. We're going to add it onto our first domain, which is A plus 1 plus A, because we've moved it across by A units. So we need to add that on so that our starting point is at 1 plus A. And since it needs to be 9, the width needs to be 9, we're going to add A to our 10 as well, so that our shape has the same width. And as you can see, we have just, I'm just going to remove this, we have just created our translation of the shape, and we've generalized it so that we can easily move it around. So now let's try and generalize our hyperbola so that we can scale it. So we want to keep the image of the shape the same, and we just want to scale it outwards. So there is a rule for doing this, which is called the proportional scaling rule. So let's explore that together and figure out how we can scale the shape. This is our actual shape that we started off with, and what I've done is made a scaled up version of it. So what I've used here is called proportional scaling, and this is done by proportionally scaling it, basically. So first we need to figure out the horizontal scaling and the vertical scaling. So to do the horizontal scaling, we normally divide x by k, and that is going to give us the horizontal scaling. And then what we do, so every x becomes x divided by k. Okay, so what I've done here is this whole thing actually ended up being x divided by k. So we're gonna I'll just show this to you what that looked like. So x divided by k. X minus a. So this whole whole denominator gets divided by k. Now this is the horizontal kind of stretching. So when we kind of had this in a fraction, so 5 was up here, and that was dividing this whole thing. So this whole thing was the denominator. What I could do was send the k up there because of the rules of fractions. And this is the same thing. So now to do the vertical scaling, we had to go ahead and multiply everything by k. So that included this value, the 2 values. So I went ahead and multiplied this whole thing by k, so that became 5k squared, and then 2k became 2k. And instead of we could even just start off by this without the translation, so that would just be x divided by k, which turned into 5k squared over x. And then we can add on our translations, which helps us move this scaled version as well. So we can scale it up, as you can see, and it's like the same image, right? And we can move it around very easily. right? So that is how we can scale and we can translate hyperbolas. Thank you so much for watching this video.